Okay, so let's look at on this example. Okay, for all n element of integers, positive integers, right? So positive integers start from 1, 2 until any numbers, right? Okay, and the summation I from 1 until n of I is equal to 1 plus 2 plus 3 plus until n equal to n plus 1 over 2. So this is our proposition or our theorem, and this is our Pn. Okay, so for the first step, we need to verify that the first statement is true. Okay, for integers, positive integers, the first element is 1. So that's why we need to check whether P1 is true. Right? We need to verify that statement. So we let n equal to 1. So we look at on the left hand side. So P1, so the summation definitely from 1 until 1, right? Because originally it is from 1 until n. So now since our n is equal to 1, so that's why the summation I from 1 until 1. So we have it is equal to 1. So the right hand side is n plus 1 over 2. So we need to replace all the n equal to 1. So the right hand side also you get 1. So since we can see that the left hand side equal to the right hand side, therefore the P1 is true. So that is the first step. Okay, in the second step, we need to assume. Okay, assume that for n equal to k, pk is true. So this is our statement pk. Okay, where you need to replace all the n with k. So now our arbitrary value is equal to k, right? So you replace all the n that we have in the original question with k, right? For all k equal to a k element of positive integers. So that is the second step. Okay, for the third step, we need to show that pk plus 1 is true. Right, so where we need to let all the n equal to k plus 1. So this is our statement for pk plus 1. Right, so we replace all the n that we have in the original question with k plus 1. Okay, so if you look at here, we simplify the statement that we have on the right hand side, where we have k plus 1 plus 1. So that is equal to k plus 2. Okay, from this pk plus 1, we have the right hand side and the left hand side. Right? So we can see that originally from 1 until k, 1 plus 2 plus until k, that can be defined as the summation I from 1 until k. Okay, plus k plus 1, right? So we have additional terms. So the whole thing here will be pk plus 1. Okay, so now we try to solve what we have on the right hand side, on the left hand side first, right? So we look at what we have on the left hand side. Okay, where we get this? So this is from the second step, which is we already assume that pk is true, right? So it will be equal to this. So you can refer to the second step. So plus k plus 1. Okay, then we need to do some algebraic manipulation in order for you to get this one. Okay, then you can see that the left hand side here is similar to what we have on the right hand side. So therefore, since left hand side to right hand side, therefore we can say that pk plus 1 is true. Okay, so after you have shown that, after you have shown step 1, step 2, step 3, then don't forget the concluding remark, okay, where we can make a conclusion. So by using principle of mathematical induction, Pn, so this is the question, is true for all n element of positive integer. Right?